This is a quick follow-up to my previous video. I just want to show you how to use DataMapPlot and Toponymy, the other library that goes with it, so that you can make a map with annotations, LLM generated annotations for your own documents. So I've created a notebook for that. Let me share my screen. Okay. So this is the same drive folder as you've seen before in my other video. Link down below. Essentially, the new notebook I've just added is DataMapPlot Basic. You can just open this, just so that I leave it untouched. I will copy it so that I can modify it. Here it is. So if you try to run this entire notebook, it's not going to work because you need an OpenAI API key. You've seen that before. So what you're going to do, is it running? Yes, some part of it will be running, but some part will be failing. What you need to do, you need to go into to log into your OpenAI platform interface, go to your API keys and use one of your keys or generate a new one. Let me delete this key, create a new one. Creating this key, which I will delete later on. Okay, I have a new key. I'm going to paste it here. And this will be needed for the code. Also note that sometimes when you run this second cell, the one that installs stuff, so this is, installing Toponymy, DataMapPlot, and ChromaDB, sometimes it asks you to restart your runtime. Yeah, restart your session. Just do it. So it means you have to run it once. Restart, and then you have to rerun everything. This is completely fine. Just a glitch that comes with installing those libraries. So now I have put this, and then my code will be able to go through all of it, except something else, which is you need a source document. And the source document in this case is the chunks.csv. It's a long CSV with sentences here that come from that I have extracted from a PDF. You know that it's one of the other notebooks here. I'm just going to download that. Actually, I have already downloaded it. So, if you want to run this, just download chunks.csv on your computer or use another CSV. You can specify what is the name of the column that contains the text in case you have a different CSV than this one. And then you can upload something. This file, I'm going to upload that. Okay, the file is there, and the text column is indeed named chunked in this case. This is the naming that comes from the notebook that does the chunking. You remember that chunk document, so that's where it comes from. Okay, so running these settings, installing the libraries. This should work now. Importing the libraries. This is just preparing stuff, but it's a little bit long because the sentence transformers need to download a number of things. Those are like relatively big models. And then what we'll do after this is to load the data from the chunks file and look at what it looks like. And you will be able to see that it presumably will be loaded correctly, and we will have two columns, one with the text and one that gives the number of the chunk when we chunk the document, so that we could reconstruct it if we needed to. But if you have other columns, because you use a different CSV, it's going to work exactly the same, and you could see them here. Sorry, I have to wait. it is not very quick. But that is how it is. At least you in the video, you can skip ahead, and I have to wait. This is too slow. It went through. Okay. Okay. So you can see here the documents, just my 2 columns. And what we're going to do now is we're going to compute the embeddings using ChromaDB. So ChromaDB is a vector store. What it does is it's going to transform every chunk into a vector and is going to store it. And we could use that to do retrieval augmented generation. You've seen that in the other video. But basically, to make the map, we need to compute the vectors and then to apply dimensionality reduction. That's what we will be doing shortly. This also needs to download some stuff. Basically, also a sentence transformer. We've got to be a little patient. So this initial downloading moment, you will do it once and for all, like once in your session, and then it's going to take as long as you have many documents. Here in my case, I don't have that many documents, but if you had many, it would take potentially quite a long time. So this is computed on the machine itself. It's not calling any API, so you would not need to have an OpenAI API for this. But yeah, so this would work on your own computer, but not what is coming after this. It should not be too long because we don't have that many chunks. We wait until this is done. This machine is very slow. It might be quicker if I choose another runtime, but it seems to have ended, so I'm going to leave it as it is. Okay. Now let's run the dimensionality reduction. Hopefully it will be a little bit quicker. So this, when done, is displayed here. The vectors have been computed. Here I'm just retrieving them because I need to pass them on to UMAP. Then UMAP is the part that is doing the dimensionality reduction. This is now done. And so at this point, we have data points that have coordinates. So what we can do is just plot them. Here I am using DataMapPlot, but in a very basic way. So DataMapPlot just makes a map with the dots. What does this mean? I don't know yet. So this is where the next library, Toponymy, is going to come into play. So Toponymy is like made by the same people who do DataMapPlot. Toponymy will find clusters. So we're going to try to find at least 4 clusters. Running this code. And if your data is really big, it may find clusters in multiple layers, but in this case, I ran it before, and it only finds 1 layer. That's because we don't have enough data points. Yes, okay, done. And now, so now we have 4 clusters that have been detected in this map, but we need to name them. That is where we would need a large language model. So here we will create this connection to OpenAI, and that's why we needed the OpenAI key. So it is testing whether this works or not, and it apparently fails. But in my test, the rest of the code used to work. So maybe ignore it. I don't know really what is going on. Maybe I'm doing something wrong. And then I will also need to download another sentence transformer. So here I could download the same as the one I have used to set up ChromaDB. The one I have used to set up ChromaDB was multilingual E5 large instruct. And that's the one that has the best performances for Scandinavian languages. So because you guys may use Danish typically, I chose this one. But it could, it could be the same. In the documentation of Toponymy, they say that it doesn't have to be exactly the same as the one you use for your to compute your vectors. It just has to be similar enough, and this one is similar enough. This one, all mini LMs L6v2 is also very good, also multilingual, and I think it's the default one for ChromaDB. So, no. But just so you can see here, I'm using another one. Oops, this is empty. Yeah, and now I am running Toponymy. So what this is going to do is to create labels for the clusters. And I should, and I've left that this way, but I should write a better description here. Basically, you know what you're doing. So instead of using my chunks, you should describe what your corpus is. Give a title and then describe, give a short description of what this is. This is going to help the large language model to write the descriptions of your clusters. We can leave it as it is. So the topic names have been generated. We can just monitor them, so just look at it. They have names that seem fine to me. We can run the code, okay. And now we can plot the same data point as before, but then it's going to add the 4 detected clusters. So we have a better static map. And we can generate even an interactive map. Yes, sorry, I wanted to scroll up. Yeah, so now we have an interactive map where we can, with the scroll and the mouse, we can zoom and we can pan and we can look at the different areas of the map. So we don't have apparently this doesn't really tell you what the data points are. This might be more advanced stuff, but if you have a very big map, maybe you don't want to read each data point, you just want to read what the small annotations are and what the big annotations are. But so this would work. You may have different layers of annotations and you could explore through this. And that's all I have for you here. So this was the use of toponymy, so to detect the clusters and generate the cluster names, and DataMapPlot to produce an annotated semantic map with cluster detection and annotation for the clusters. Bye.